Okay, so today I'm going to introduce everybody to some basic things about waves and some basic equations that describe some things about waves. So we're going to start our discussion about waves with some string. So cut two different lengths. And I'm going to put a knot in each end. Where this Boy Scout training came in handy. One knot, it's an overhand loop. Make sure that's the right length. Put it in there, and voila. Alright, so we'll hang that right here. One knot. One string, we'll have another string. Here we go. In one end, and now we'll put it in the other end. This is going to be really short. That's good though. Alright, so as you can see, we have two strings of different lengths, just like that. And I'm going to get two weights out here of equal mass. Each one of these weights is 100 grams. So we'll hang this weight here, I'll hang this weight here. Now remember, this is a discussion about waves. Okay? So, when I swing this, it's making a wave. And when I swing this one, it's making a wave, but the waves have different properties. So, turn this so that you can see it. Perfect. And now you'll be able to see the different properties of the waves. So when I swing this one, note what happens. When I swing this one, note what happens. Now let's swing both of them together. And this will illustrate the difference between the waves. So you see what's happening here is the shorter one is actually vibrating back and forth faster than the longer one. And that's because the basic rule for a pendulum, what we made right here, is it's controlled by an equation, okay, that describes the relationship. Probably come back to that in a minute. So the equation that we're going to use is this. T equals 2 pi square root of L over G, where T is equal to the period, L is equal to the length of the string, and G is the acceleration due to gravity. And on Earth, the average number that we use everywhere is 9.8 meters per second squared. So when I bring this pendulum back in front, we can play around with this, and then we'll describe how this relates to waves. If I were to take this big heavy weight, this is 500 grams, and replace it with our pendulum. According to our equation, it shouldn't affect the period at all. Okay, so the period, what that's talking about is it's the amount of time it takes for the swing to happen. Okay, so if it goes from here to here and back, the amount of time it takes for that to happen, that is the period. So if I swing this, that would be the period. So I put the lighter weight on here, swing it from the same distance. Note that there's no change. And we could measure that, and there would be very little change. Of course, in physics, the equations, they don't always capture what's going on in the reality. There's always sources of error in the system. You know, there could be friction up here. There's air resistance in the bigger weight and other things. So there's always little margins for error. But typically, this sort of thing, this relationship, holds true. So what this is saying, if we've got the period of our pendulum here, if this has a period, okay, what's going on is somehow related to waves. So if I swing like this, there's a vibration going on. And that vibration is important because all waves really are just vibrating energy. Okay? So if I cause the medium to vibrate here and I slap the water, I'm essentially doing the same thing. So in a pendulum, the wave is controlled by the length of the string. Okay, so that's telling you something about the medium that the wave is flowing through. Gravity affects all waves. Gravity is something that makes waves happen, and it makes it controls a lot of the different properties of how the medium is going to flex and move. And the period is the result. That's describing something about the wave. So let's take a look at this. I want you to imagine if we were to take a piece of paper and curve it, and put a pen on the bottom of this, and swing it, and then push the paper through, like that, towards you. Here's what you would see. So, here's what you would see if we were to do that. You would see that waveform right there. Now, the period is the time it takes for one place on the wave, let's say the crest of the wave, to pass a certain area and get to here. So the time it takes from here to here is the period. And we call that letter T. Okay, and we talk about period in the terms of waves per second. Excuse me, it's seconds per wave. So, seconds per wave. Now, the opposite of period, if we were to flip this over, okay, what it ends up being is that's waves per second, okay, and that is what we call frequency. Okay, so frequency F is describing how many waves are passing a certain point in 1 second. Okay, and so that would be waves per second. Okay, so note that basically these two equations are flip-flops of each other. They're reversals. All right? That's why we say it's the inverse. So when we're talking about the equations that describe these waves, here's the basic equations. So T equals 1 over F. And F equals 1 over t. And this is describing that relationship where it's just flip-flopped. Okay? So if we're talking about frequency, we're saying here's an observer, and he's going to count the number of waves that pass that point in 1 second. And if we're talking period, we're going to say, okay, here's that observer. I'm going to measure how many seconds it takes for that whole wave to pass me. All of this leads into some other properties of waves that I wanted to talk about. Okay? So velocity is measured in meters per second, or distance over time. Okay? And if we're going to talk about how fast a wave is moving, we need to talk about it in terms of distance, the amount of distance it covers over time. Okay? Another property of waves that's really important is this whole idea of how long the wave is. That's wavelength. If we were to measure from this point to this point here, we'd call that the wavelength of the wave. And this has a Greek letter that we use to describe the wavelength of the wave. Okay, so this Greek letter is lambda. And if we were to take this figure right here and think about which one of these it corresponds to, it would be distance. So the first part of our velocity equation for waves is v equals wavelength. Okay? So now, think back to the period and frequency that we just were talking about. If we're going to think about a number, okay, if we're going to think about a quantity that would give us the time, okay, the amount of waves in a second, okay, that's frequency. But that would give us the time for this wave, because frequency is F equals 1 over t, okay, or period. All right. So the speed of the wave is going to be determined by the wavelength times its frequency. Okay, and that's how it works. If you're sitting here and you are watching wave trains go by, okay, and if they have a really, really long wavelength, but they have a really high frequency, okay, those waves are moving really fast because they're covering not only a lot of space, but a lot of them are moving past you at once, really, really fast, in 1 second. Okay. Now, if we are in a different situation where we're watching a long wavelength wave move past you, and it's moving really, really slowly, like the frequency of those waves is very low, then that wave is moving a lot slower. So, back to the pendulums. Okay. So if I get this pendulum swinging, the amount of times that one vibration happens would be its frequency. If I get this pendulum swinging, the amount of times that this vibration happens would be its frequency. If we're going to think about the wavelength of these waves, it's related to its frequency. We could measure the speed at which these waves are propagating, okay, and start to figure out what this equation might be. Okay, but we're going to save that for another day. Basically, what I want you to get out of this is that pendulums and waves are similar. You're basically just adding energy to a medium, and when you do that, you get some different equations that you can use to describe some basic properties of waves. It's related back to the waveform, and all of these quantities are interrelated. Thank you very much.